consider some jam questions. We have the first question here is a catapult used to hold a stone of mass 500 grams. So solution, we have the mass is given as 500 grams, and then we also have is extended by, so we have S. We have our S is equal to 20 centimeter. That's the distance covered with an applied force. So F is TF, and applied force F. So if the stone leaves with a velocity, so velocity is equal to 40 meters per second. The value of F is, so we're asked to look for this F. Now, before we try to look at how we're going to solve this, let's convert this. This is because the standard unit of mass is kg, so we divide this by 1000. By 1000. Divide this by 1000. So we have 500 divided by 1000. We have 0.5 kg. They also have, this is also in centimeters, so the standard unit of distance is in meters. So we divide 20 by 100, because 100 centimeters will give us 1 meter. 100 centimeters will give us 1 meter. So when we divide 20 by 100, 20 by 100, we have 0.2 meters. So this is what we have. We don't need to change velocity. Velocity is already in its own standard unit. So we know that we're looking for F. So there's a relationship between these quantities. But what we're going to consider is the work done by the catapult equals the energy of the stone. That's the energy the stone possesses. And we know that anytime an object is in motion, it possesses what is called kinetic energy. So we're going to say work done. The work done by the catapult is equals to the kinetic energy. Kinetic energy. And work done is the same thing as force times distance, which is equal to the kinetic energy here, mv squared, the formula for kinetic energy. So you substitute our values. Now we have F times, what's our S? Our S is, I will change it to 0.2 equals half, 1 over 2 times the mass here is now 0.5 times our velocity is 40, so 40 squared. So F times this is 0.2F equals, we'll just change this quickly, 1 over 2 times 0.5. If you square 40, you are going to have 1600. That's what you have, 1600. And so if we have this, we can just say 2 here, 1, 2 into this, 2 into 16 is 8, have 800. So have 0.2F equals 1 times 0.5 times 800. Now, if you have this, you can make F the subject formula by dividing both sides by 0.2. So 2 cancels to have F is equal to 0.5, because 1 times 0.5 times 800. So it's still the same thing as 0.5 times 800. 0.5 times 800, we have 400. 400 divided by 0.2. Divide by 0.2. What you have is 2000. So have F is equal to, write this in standard form, 2000. Writing this in standard form, that is 1, 2, 3. So have 2.0 times 10 raised to the power of 3 Newton. So our answer is option C. Option C is our answer. Now let's look at another question. Now let's look at this. The velocity V of a particle in a time t is given by the equation V equals 10 plus t 2t squared. Find the instantaneous acceleration after 5 seconds. So these are the options given to us, A to D. So solution, Now what we are given is V is equal to, so we have given, we have V is equal to 10 plus 2t squared. Now, and then we are told that we should find the acceleration when t is 5 seconds. Now, what you have to do in this question is very easy. You just to apply the simple principle of differentiation. Now, the relationship between velocity and time, of course, the question even told us the relationship between velocity and time is acceleration. So acceleration here is the same thing as the v over the t, because that's what you have. You have v and t. So whatever you have here and here, that's what you are going to differentiate. So dv over the t is equal to, so we're differentiating this dv over the t. Now differentiation of a constant is 0 plus differentiation of this. Now we're going to bring down these two, this power, you bring down the power, multiply what is here, then reduce the power by 1. This is what I mean. Differentiation of a constant is 0. So 0 plus, bring down the power to multiply the whole of this term, 2 times 2t, then reduce the power by 1. That's differentiation. So we now have our acceleration still, dv over the t will give us, what you have here is 0 plus 2 times this is 4t. So what you're actually having in essence is a is the same thing as 4t. And it told us that when t is 5, so when t equals to 5, we should find a. So a is equal to 4 times t, which is 20 meters per second squared. That's the unit for acceleration, 20 meters per second squared. Now we did a work on dimension on how to get this unit. If you check one of my videos on dimension, you know how we got meter per second squared. That's the SI unit for it, the standard unit for this. So we have 20 meters per second squared. That is the answer to this question. And let's also see another question. Now let's also see this. A cell of internal resistance 1 ohms supplies current to an external resistor of 3 ohms. Now the efficiency of the cell is, so we have to look for efficiency. Now solution, we have a cell of internal resistance. So internal resistance is presented using the small letter r, is 1 ohms, supplies current to an external resistor. So external resistor is represented using capital R, which is 3 ohms. Now the efficiency, so efficiency is always, we can use this sign for efficiency. So efficiency is question mark. Now the relationship between internal resistor and external resistor, or internal resistance and external resistance, is given as this: efficiency, that's is equal to the external resistor over the external resistor plus the internal one times 100 over 1, or 100%. Now we substitute our values. Now we're going to have efficiency. Okay, let's have efficiency will be equal to R. Here is 3 over 1, 3 plus, that's 3 plus the small r, that's 1, times 100. Now what we're going to have is 3 over 4 times 100. Now what we'll do is this: we divide and then multiply. So we have 3 divided by 4 will give us 0. Let's have it like this. Our efficiency is equal to 3 over 4 times 100 Let's put it by 1. So we have efficiency is going to give us 0.75 times 100. To multiply this 75%. So this is the answer to this question. So the option that is correct is A. Option A is the right option. So don't forget, this is a relationship we're supposed to use for this efficiency, for this question in particular. Thank you for watching. Do not forget to like, to share, and to subscribe. And don't forget, understanding connects us to the world.